A cricket ball pitches outside the leg stump. Normally, it should continue straight past the batter. Instead, it aggressively rips sideways, crashing into the stumps. Leg spin generates deception through the high-velocity rotation of the ball. This relies on the precise application of torque at the moment of release to manipulate the air and the surface of the pitch. No one weaponized this manipulation more effectively than Shane Warne. He revived the discipline in the modern era, turning the delivery into psychological warfare. He built his mastery on the foundations laid by pioneers like Richie Bennett, who kept the intricate technique alive through decades dominated by raw pace. The effectiveness of this delivery stems from the synchronization of biomechanics and fluid dynamics, forces that combine to create an aerial path the batter cannot easily anticipate. The setup starts with a very specific grip: 2 fingers up, 2 fingers down. The ball rests with its seam parallel to the palm. The index and middle fingers spread across the top, while the ring and pinky fingers tuck tightly underneath. The thumb must remain completely loose, or even entirely off the ball. Pressing it against the leather introduces unwanted friction and reduces the rotational spin. The power for that spin starts in the lower body. A leg spinner utilizes a delivery stride extending to roughly 52% of their total body height. When their back foot lands, the rear knee flexes to 53 degrees, absorbing force and storing elastic energy. As the arm moves through its arc, the wrist cocks back. The release requires a rapid snap of the wrist from right to left, a movement similar to a car windshield wiper. At the point of release, the ring finger forcefully flicks the seam, while the palm faces toward the batter. This mechanical torque translates directly into the high rev rotation required to bend the ball's flight path. A professional leg spinner can impart well over 2,000 revolutions per minute. Once the ball is in flight, its trajectory is governed by fluid dynamics, specifically an effect documented by the physicist Heinrich Gustav Magnus. As the spinning ball drags a boundary layer of air, it creates high and low pressure zones. This differential pushes the ball sideways mid-air, known as drift. With topspin, this Magnus force points downward, combining with gravity to make the ball dip. The human brain predicts the arrival of a projectile by calculating a standard ballistic arc, a curve shaped by forward momentum and gravity alone. By introducing drift and dip simultaneously, the bowler moves the ball onto a path the batter's visual system has not calculated. The bowler must land the ball within a specific 2-meter good length zone on the pitch for these forces to be effective. This scatter plot maps forward speed on the x-axis against vertical speed on the y-axis to hit the 2-meter target box. A bowler has a 16% margin for forward speed, but only a 4.3% vertical tolerance. A tiny upward miscalculation causes a complete miss. Because the vertical margin is so narrow, attempting to vary the height of a trajectory is mathematically risky. For most bowlers, varying the forward pace is a much safer way to induce a mistake. Every successful leg break requires the body to instinctively solve this hypersensitive physics equation in a fraction of a second. When the ball impacts the ground, aerodynamics are replaced by surface friction. As the anti-clockwise rotating ball makes physical contact, the surface of the pitch opposes that rotation. This friction creates an instant pivot point, converting the ball's angular momentum into a sharp horizontal turn from right to left. Spinners often prefer an older, scuffed cricket ball. The raised stitching and roughened leather increase the contact time with the ground, providing more texture for the pitch to grip. The pitch acts as a mechanical multiplier, taking the aerial deception of the flight and converting it into aggressive ground movement. A bowler uses variations to exploit the batter's expectations, delivering different physics while maintaining the same arm action. The googly, shown here, reverses the directional torque. By releasing the ball from the back of the hand, the bowler makes the ball rotate clockwise, causing it to turn into the batter instead of spinning away. The flipper uses backspin. This removes the Magnus dip, causing the ball to stay low and skid off the pitch faster than a standard delivery. This variety forces the batter to guess the physics of every delivery. They can no longer rely on their visual training to predict the bounce or the flight path. Mastering the leg spin is the art of controlling invisible physical forces to exploit the limits of human anticipation.